7 days ago, something changed. Astronomers monitoring the interstellar visitor known as 3I/ATLAS noticed readings that simply shouldn't exist. Not the kind of errors that come from calibration or dust on a lens, but data that openly defied physics, measurements that laughed in the face of everything we thought we knew about comets. The first to notice were the teams in Chile, tracking it through the morning haze. Their instruments detected spikes, massive, abrupt losses of material, jets that should have torn the nucleus apart, color shifts that painted the coma an unnatural blue. Within hours, independent observatories confirmed the same impossible behavior. And when NASA verified the readings, there was no doubt left. Something extraordinary had happened. For weeks, 3I/ATLAS had vanished behind the sun's glare during solar conjunction. When it emerged again, it was no longer the object scientists remembered. It had changed, radically, inexplicably. Before conjunction, the comet had been stable, predictable, a visitor behaving within the boundaries of physics. After conjunction, it was as if something had rewritten its rules. New jets burst from its surface. The coma ballooned to 3 times its prior size. Spectral lines danced in ways no model could explain. "This shouldn't be possible," one astronomer whispered during a late-night call at the European Southern Observatory. Yet the data kept arriving, relentless and unambiguous. 3 independent instruments, 3 continents, 1 truth. 3I/ATLAS had come back transformed. NASA's Jet Propulsion Laboratory released a preliminary statement. It spoke carefully, scientifically. But behind every sentence, the astonishment was clear. Non-gravitational acceleration exceeding predicted limits by orders of magnitude. Material outflow that defied thermodynamic models. Spectral anomalies hinting at exotic compounds. The phrase "requires further investigation" appeared 6 times in a single page. When scientists looked closer, they found the transformation too sudden, too violent to fit any normal progression. Prior to conjunction, 3I/ATLAS had been cooling, retreating from the sun. Activity should have diminished. Instead, it erupted. The rate of material loss increased tenfold, not gradually, but instantly, as if something sealed inside had burst free. Hydroxyl emissions, evidence of water sublimation, spiked far beyond expected thermal levels. Carbon dioxide surged even higher, breaking every known ratio. At such distance from the sun, the energy input should have been minimal, yet the comet was behaving as if it were burning from within. That was the first mystery. The second came when astrometric data revealed its orbit had shifted. 3I/ATLAS was no longer where gravity said it should be. Precise tracking from JPL showed the deviation unmistakably, an acceleration that could not be explained by gravitational forces alone. Normally, asymmetric jets of gas can act like thrusters, nudging a comet slightly off course. But here, the magnitude of the deviation was impossible. The momentum transfer required would demand a thrust beyond anything natural. At the same time, color analysis revealed something else, something beautiful and unsettling. Before conjunction, the comet's coma reflected a neutral tone, typical of dusty silicate and carbonaceous material. After conjunction, it glowed an intense blue, a hue more commonly associated with ionized gases than with solid dust. Spectrometers pointed toward carbon monoxide ions, but even then, the signature was too strong, too pure. It suggested a chemistry unseen before in any solar system object. Some called it alien chemistry, others called it a riddle. When the James Webb Space Telescope turned its instruments toward the comet, its sensors picked up an unfamiliar emission at 4.5 micrometers, a wavelength associated with heat but not with any known volatile compound in standard cometary models. It was as if something within the nucleus had begun to burn, not chemically in the way we understand, but through an energy process no one could easily name. Within a single week, 3I/ATLAS had gone from a curiosity to a cosmic enigma, the kind of enigma that doesn't just challenge data, It challenges belief. Scientists who had built their careers modeling the behavior of comets found themselves staring at graphs that looked like fiction. The comet was not supposed to accelerate that fast. It was not supposed to release that much mass. It was not supposed to glow that color. And yet, there it was, shimmering at the edge of our understanding, daring physics to keep up. NASA held an emergency symposium, virtual, global, attended by teams from every major observatory. They compared notes, calibrated instruments, ran simulations. Every test came back consistent, no sensor malfunction, no data corruption. The phenomenon was real. That's when the question changed from what went wrong to what did we just witness. The leading hypothesis pointed toward perihelion, the comet's closest approach to the Sun, which occurred during the period it was unobservable. That was when 3I/ATLAS had been hidden behind the solar glare, untouchable to telescopes on Earth. If something catastrophic had happened then, if pressure had built inside the nucleus until it fractured, no one had seen it. When the Sun released its grip and the comet emerged, it bore the scars of that unseen transformation. Some imagined a sudden rupture, a venting of ancient reservoirs sealed since its formation in another star system. Others proposed internal heating from radioactive decay, long-lived isotopes like uranium or potassium-40, producing enough warmth to trigger sublimation even in the freezing dark. A few dared to whisper of exotic chemistry, molecular reactions unknown to Earth, releasing energy in bursts that could mimic propulsion. But every explanation felt incomplete, a fragment of a greater truth no one had yet uncovered. The mystery deepened when Hubble captured high-resolution images showing structural deformation in the nucleus. One hemisphere appeared fractured, almost hollowed, as though something within had melted or exploded outward. The surrounding coma shimmered with fine crystalline dust, reflective enough to amplify the comet's brightness far beyond predictions. For a brief time, 3I/ATLAS outshone every object of comparable size in its vicinity. To the naked eye, it would appear as a faint, icy sapphire moving slowly across the background stars. To scientists, it was a statement written in blue light: your physics is incomplete. Even the most cautious voices admitted it. "We are seeing processes we don't yet understand," said Dr. Elena Ruiz of the Astrophysical Institute of Madrid. "Our models assume certain thermal behaviors, certain molecular pathways, but this object may come from conditions that make those assumptions irrelevant." In other words, interstellar comets might play by different rules. And 3I/ATLAS wasn't the first to suggest it. The first interstellar visitor, 1I/Oumuamua, had shown non-gravitational acceleration without visible outgassing, a mystery that still divides astronomers. The second, 2I/Borisov, behaved like a normal comet, quiet and predictable. But now, with 3I/ATLAS, the pattern shattered completely. 3 visitors from beyond, 3 entirely different behaviors. Whatever rulebook governed objects from other star systems, Earth scientists didn't have it. The night sky had become a laboratory of uncertainty. Every telescope, every instrument turned toward 3I/ATLAS, recording, measuring, questioning. Data poured in, each bit a clue, each observation a reminder that our understanding was built on assumptions born under one sun. Out there, among countless others, nature might write her equations differently. This realization hit the scientific community like a quiet thunder. In conference rooms and virtual meetings, the conversation shifted from disbelief to awe. "We may be witnessing the first clear example of non-terrestrial chemistry in action," one researcher wrote, "a living experiment in how other worlds form and behave." The words spread, quoted, and rephrased, finding their way into press releases and journal abstracts. But beyond the academic precision, there was something else, a sense of humility, even reverence, because for all our equations, telescopes, and theories, the universe had just reminded us that we are still its students. 3I/ATLAS was still out there, still accelerating, still glowing, a messenger from another sun carrying questions instead of answers. And as scientists stared into the data streams, they couldn't shake the feeling that something more awaited, something that, once revealed, would force us to rewrite not just our models, but our understanding of what's possible. The comet that broke physics had only just begun to speak. When the second wave of observations arrived, it became clear that what was happening to 3IATLAS wasn't a brief flare. It was an ongoing transformation. Ground-based telescopes in Chile, Hawaii, and the Canary Islands captured the comet's image night after night, and each time its appearance was different. The coma expanded outward like breath in freezing air. Filaments of gas twisted into new geometries. Jets erupted in unexpected directions, sometimes perpendicular to the comet's motion. The changes were too rapid for simple sublimation, too structured for randomness. Astrometric data showed that its acceleration continued to increase. JPL's refined calculations confirmed that the deviation from its predicted path was no longer a transient effect, it was persistent. The comet was being pushed by something consistent, directional, and powerful. In a virtual briefing, NASA scientists displayed the new data overlay. The difference between predicted and observed positions glowed like a scar on the graph. "This isn't noise," one analyst said quietly. "This is thrust." But what kind of thrust could act upon a frozen body millions of kilometers from the sun? The outgassing explanation still couldn't hold. Even the most generous models of jet asymmetry fell short by a factor of 10. The force propelling 3I/ATLAS was too great, and the energy fueling it too mysterious. James Webb's spectrometers detected the same unidentified emission line again, stronger this time, with sharper definition. The signature hinted at complex carbon compounds reacting energetically, possibly undergoing transformations that released more heat than they absorbed. If true, it meant the comet's chemistry wasn't passive. It was active, self-driving, maybe even catalytic. In the control rooms of observatories around the world, scientists whispered comparisons to 1I/Oumuamua. That earlier interstellar visitor had accelerated too, yet without any visible tail or outgassing. 3I/ATLAS was different. It was loud, messy, chaotic, like a living engine venting light and dust into space. Two mysteries from beyond the stars, each disobeying in their own way. One silent, one explosive, both rewriting our confidence in physics. As images poured in, Hubble revealed something even more unsettling. The nucleus no longer appeared solid. Instead of a single condensed point, there were signs of internal voids, perhaps fractures or cavities where the surface had collapsed. The comet's spin seemed irregular, wobbling as though off balance. That irregular rotation could amplify outgassing from specific areas, turning the nucleus into a wobbling thruster. But still, the numbers didn't fit. The thrust exceeded the limits of any rotationally driven process. "We're looking at energy release on the scale of a controlled detonation," said Dr. Samir Kapoor during a late-night conference call. "But there's no ignition source, no fusion, no fission, just ice, dust, and sunlight, unless something else is happening inside." Speculation grew bolder. Some proposed that 3I/ATLAS harbored pockets of exotic ices, compounds stable only in the deep cold of interstellar space. When heated near perihelion, these materials might undergo runaway reactions. Others suggested internal electrical discharges, static building within the rotating nucleus until it discharged explosively, fracturing the crust. The most radical theory pointed toward magnetic interaction, currents induced by the solar wind acting on metallic compounds, generating localized heating from within. Every idea sounded improbable, yet every observation demanded an answer. Then came the most haunting discovery of all. Polarization data showed the light scattering from the coma had changed in a way consistent with the presence of crystalline structures, microscopic prisms forming spontaneously in the released dust. Such order emerging from chaos shouldn't occur naturally at these scales or temperatures. It implied molecular organization, some process driving matter towards symmetry. The universe, it seemed, was composing its own experiment in front of us. As this data circulated, public fascination exploded. Headlines declared the comet that breaks physics. Documentaries rushed into production. Interviews with physicists filled every news feed. But behind the attention, the scientists themselves struggled with unease. Because what they were seeing didn't just question one theory, it undermined the foundation of all cometary physics. If interstellar objects carried energy processes or materials unknown to our solar chemistry, then our models of thermal activity, radiation pressure, and chemical kinetics were incomplete. And incomplete models meant incomplete understanding of the universe itself. In one internal NASA transcript later leaked online, a scientist wrote, 3IATLAS is a warning that we've been studying a subset of nature, local, familiar, biased by our own environment. The universe doesn't owe us consistency. The phrase spread across social media, quoted, reinterpreted, feared. Meanwhile, telescopes continued watching. New measurements suggested the acceleration vector was not fixed but oscillating, as though the force itself pulsed. That pattern hinted at cycles, perhaps internal pressure waves, perhaps rotational exposure of active zones. Whatever it was, it had rhythm, a heartbeat. The comet's brightness also fluctuated in sync with those pulses, rising and falling like breath. It wasn't constant luminosity. It shimmered as though something beneath the surface was opening and closing in intervals. Webb detected periodic temperature spikes synchronized with the oscillations in brightness. It was undeniable. The comet was responding to something, or generating something, and still it kept moving, farther from the sun, yet refusing to fade. Normally, as comets retreat into the cold, activity ceases. Dust settles, light dims. But 3IATLAS didn't fade. Its coma remained bright, its jets persistent. Even as solar radiation waned, its energy stayed constant. Somewhere within, a hidden mechanism continued to power its release. In late-night control rooms, monitors glowed with graphs and spectra, while exhausted researchers watched in silence. They weren't just studying an object anymore. They were witnessing a message written in physics they didn't yet speak. Theories piled up, equations expanded, computer models strained, but the numbers refused to align. When NASA issued its second statement, it was both cautious and profound. 3IATLAS continues to display non-gravitational acceleration inconsistent with all known mechanisms. Observations indicate ongoing energy output not correlated with solar input. These findings suggest internal or chemical processes previously undocumented in cometary bodies. Behind the formal tone was something rare: humility. For centuries, comets had been the predictable wanderers of our solar system, their behavior described in neat equations linking heat to distance, sublimation to sunlight. But this object from beyond had rewritten the script. It reminded humanity that not all rules are universal. Scientists now face the unthinkable possibility that matter forged under another star might behave differently under our sun. Different isotopes, different bonds, different physics. The phrase universal laws suddenly felt like an assumption. As 3IATLAS drifted farther into the dark, its blue light dimmed but didn't die. Observatories recorded faint echoes of its emission lines long after it should have gone silent. Some saw this persistence as poetic, a fading signal from another world whispering that we had only begun to listen. Others saw it as scientific defiance, a challenge to every model still clinging to certainty. Somewhere in that faint blue glow was a truth too large for equations and too complex for words. A truth that said the cosmos isn't a place of perfect predictability, but of endless invention. 3IATLAS wasn't just breaking physics. It was reminding us that physics is only our language for describing nature, not nature itself. And as telescopes continued their vigil, scientists across the world began asking a new question. What else is out there, moving through the stars, carrying secrets that will once again force us to start over? Weeks have passed. since the first anomaly. Yet the mystery of 3I/ATLAS deepens with every passing night. The comet has moved beyond the reach of most amateur instruments, but the great eyes of humanity, Hubble, Webb, and the largest observatories on Earth, still follow its fading trail. What they're seeing now defies the closing act we expected. Instead of declining into silence, the comet continues to pulse. Its emissions rise and fall in a rhythm that feels alive, like a distant heartbeat measured across the void. In the latest data, astronomers detect fragmentation, multiple points of light where once there was one. The nucleus has split, possibly into 3 distinct fragments, each with its own coma, its own faint trail. Yet even in separation, the pattern continues. Each fragment brightens and dims in sequence, a chain of pulses repeating every 8 hours. The synchronization makes no sense. Random fragments shouldn't coordinate, but 3I/ATLAS never followed the rules of random chance. At NASA's Jet Propulsion Laboratory, scientists map the trajectories of the fragments. Each one drifts outward at a slightly different angle, yet their paths curve together, like dancers held by invisible lines. The data suggests magnetic interaction, maybe even resonance, forces linking them through shared fields of charged particles. It's beautiful, and it's terrifying, because it hints that the comet's interior once functioned as something more complex than a lump of ice and dust, something structured. Dr. Ruiz studies the light curve, her eyes tired from nights without sleep. "We're not watching destruction," she says softly during a press briefing. "We're watching transformation." The phrase catches on, spreading through headlines and research papers alike. Transformation, not decay. The idea that what began as a simple interstellar wanderer might now be evolving into something else. The public watches in fascination as NASA releases composite images, 3 glowing fragments trailing ribbons of vapor suspended in a vast black ocean. The hue remains unmistakably blue. That impossible color has become the comet's signature, a mark of defiance against expectation. It shouldn't exist at this distance, yet there it is, persistent as truth itself. In private, scientists argue about the implications. Some insist the object's chemistry merely reflects exotic ices sublimating in unfamiliar ways. Others believe the comet's interior housed reactive compounds capable of energy release through non-terrestrial reactions. And then there are those few who step further, suggesting that 3I/ATLAS might not be entirely natural at all. Theories surface quietly in message threads and encrypted forums. Could it be debris from an ancient technological process, fragments of engineered material launched from another star system long ago? No evidence supports the claim, yet the mystery invites imagination, and imagination refuses to stay silent. But within the scientific community, humility prevails. The majority agree on one thing: 3I/ATLAS has forced us to see the limits of our understanding. It has reminded us that space is not a known territory. It is an infinite frontier where even the laws we hold sacred may have exceptions. As the fragments drift farther from the sun, their brightness fades slowly, but not completely. Each pulse grows fainter, stretched across greater distances, until the signal merges with the background noise of the cosmos. The comet is leaving us, returning to the dark interstellar sea from which it came. And yet, the data it leaves behind will ripple through decades of study. Every frame, every spectral line, every unexplained acceleration, each piece becomes a question that future generations will try to answer. NASA's final report concludes with an unusual sentence. The behavior of 3I/ATLAS suggests that interstellar objects may embody processes and materials unknown to solar system science. Continuous observation of such visitors is essential to expanding our physical understanding of the universe. In the language of institutions, that is as close to awe as one can write. As the last confirmed images arrive, something unexpected happens one final time. A faint flare, a glimmer far beyond the main fragments, emerges and then fades. It lasts only seconds, Some say it's a camera artifact, others a reflection, but those who have watched this comet from the beginning sense something different, a farewell perhaps, or the last exhalation of a traveler from another sun. In observatories from Mauna Kea to the Atacama Desert, astronomers stand in silence as the data stream ends. There's no applause, no conclusion, only a deep awareness that they have witnessed the impossible and recorded it faithfully. Somewhere out there, 3IATLAS drifts between the stars again, carrying its secrets intact, perhaps to astonish another civilization one day. Back on Earth, under night skies that now feel a little larger, the conversation continues. What if there are countless others like it? Objects formed in alien furnaces, shaped by unfamiliar chemistry, wandering through the interstellar dark. What if each one carries a different lesson about what matter can do, about what the universe allows? For now, we have only questions, and the echo of a blue light fading into the abyss, but perhaps that's enough. Because in its defiance, 3I/ATLAS has given us something rare. The reminder that knowledge is not certainty, that science is not static, that wonder is not a weakness, but the beginning of understanding. The comet that broke physics continues to haunt our data, our thoughts, our dreams. It didn't arrive to give answers. It came to remind us that answers are temporary. Somewhere beyond the solar wind, its fragments still drift, still pulsing faintly in the dark, their rhythm carrying a message older than language, that the universe will always surprise us, and that the search for understanding is the most beautiful pursuit of all.